Hi everyone, so on this video I'm gonna explain about networking models, and there's a outline, so I'm gonna explain the number one. There's a concept. So networking models is related to computer network because it refers to interconnected computing devices that can exchange data and share resources with each other. So is networking models the same as computing network? The answer is no, because networking models is rules that define how a group of computers can communicate with one another. So networking models allows each vendor to making their own rules so they could communicate with each other. Currently, there are two well-known open standard networking models. There are the TCP or IP models and the OSI model. So the OSI models is created by the International Organization for Standardization, also shortened as ISO. And there's TCP or IP models is created by U.S. Department of Defense. And the shortened as TOD. Next, before the existence of networking models, each vendor created its own network system. But in 1974, IBM developed the System Network Architecture, or SNA. As a result, different vendors could not communicate with each other before networking models were established. And after the existence of networking models, the vendor could communicate with each other because they followed the same set of rules. There's an example. The vendor one is MikroTik, this is IBM, and this is TCP. They all could communicate because they followed the same set of rules. Next, there's TCP or IP models. It's a type of networking that is commonly used today. It defines a protocol that allows main computers from different networks to communicate with each other. To make it easier to understand, each networking model is divided into smaller parts called layers. In documentation, the TCP or IP models consist of 4 layers. But in real network implementation, it is often divided into 5 layers for easier application. So there's TCP original. There are 4 layers, and the first one is application. The second is transport. The third is internet, and the fourth is network access. I'm gonna explain the application first. So the application layer is It functions as an interface between the network and application. So there's an example when a client requested to a server, then the server would respond to the client like it is successful or an error. And there's examples of services in the application layer include HTTP, FTP, SMTP, IMAP, SSH, and others. HTTP is used when setting up or managing a web server. It looks like just what I example it. Like when a client is requested, the server is answered it. Okay, next. There's a transport layer. It functions to provide data transfer services to the application layer. This layer commonly uses two main protocols, TCP and UDP. TCP is more reliable because it supports error checking, so it could be used in various. TCP is typically used for IP communication that requires accuracy. UDP is faster but does not provide error checking. So TCP is typically used for IP communication that requires accuracy. You could check your IP communication that requires accuracy. UDP is used for video streaming, online games, and other applications that requires high data speed. So there's a picture that explains a web server wanted to request to web browser. It requested through a HTTP header and TCP header, but the TCP header is a segment, so it cannot be sent through the web browser. So the web server request didn't answered by the web browser. It could be caused by a network error or others. Next. There's a network layer. There is only one main example in this layer, which is IP or Internet Protocol. IP provides two essential features, addressing and routing, which handle connectivity and path selection. Every network device requires a unique address. Addressing refers to the IP address of the device itself. Routing is a feature provided by IP at the network layer to manage the flow of data being sent to its destination address. So, for example, there's a PC. This number is the PCA's IP address. This number could be a path selection to communicating with this PC. And with this number, PCB could communicating with a PCA. For example, when this PCA is requested something, PCB could answer it because they have an IP or Internet Protocol. IP is located in the network layer, layer 3 of the OSI modules. IP is used for communication between network devices. So this number could be used for this computer to communicate. There are two types of IP address. Number one, first is IP version 4 that use a 32-bit of addressing by divided into 4 blocks, each containing 8 bits. And this is the format for the IP version 4. And the second is IP version 6 that use a 128 bit of addressing by divided into 8 blocks, each containing 16 bits. And this is the format for the IP version 6. Next, there's a data link layer and physical layer. The data link layer defines the protocols required by the physical layer. One of its case feature is FCS, or shortened from frame check sequence, which is used to detect error without recovery. So the key feature is FCS, which is used to detect error without recovery. And the addressing method this computer uses in the data link layer is the MAC address. The addressing method is use MAC address. Now, the physical layer defines the cabling and the physical connections used to link devices within a computer network. So, what device to use for this computer so they could communicate both wired or wireless. Next, we have the encapsulation and decapsulation. Encapsulation is the process of wrapping data with headers at each layer, while decapsulation is the reverse process, where those headers are removed as the data moves up through the layers. So there's a picture that contains a data. Let's zoom in. If we directed it to application, then it will be directed to data. If we directed it to the layer of transport, it will be directed to data, but it would add one more, and it's a segment header. If we direct it to a network, then it would be added one more layer, a packet header. Then it would be data, segment header, and packet header. If we directed it to the data link, then it would be added one more layer. It's a frame header. Then if we directed it to the cycle, it would show a converted data from this layer. This all would be converted into a bits. Okay, next, there's OSI models. Currently, the TCP or IP model is the most commonly used because in terms of protocol and model development, TCP or IP is more dominant than the OSI layer. Before the existence of networking models, each vendor had its own network, making communication between vendors difficult. The OSI layer is commonly studied and easier to understand. Building a computer network required a huge effort because many vendors had their own networking system, making communication between them difficult. Therefore, in 1984, the ISO created a minimum specification model known as the OSI 7-layer models, and this is the table of OSI model and the TCP models. The OSI model consists of 7 layers. The upper layers are related to user interface, data formatting, and communication session between layer 5 to 7. The lower layers are related how data is transmitted and flows across the network between layer 1 to 4. And here we go. This is the end of the video. Thanks for watching.